All right, in this lesson we're continuing to study regressions, best fit models, both linear, quadratic, and exponential. And in this particular case, we're just going to, so we're going to continue the lessons here. There's been several ahead of this. So in this problem, we're looking at the time after a football is thrown versus its height. So in order to do this, what I've shown you in previous lessons is that we need to enter the data. So here's the process. Turning the calculator on. Press Stat, Edit. Whatever's there, I'm going to come up to List 1 and hit Clear, arrow down. Come over here to List 2, hit Clear and arrow down. List 1, I'm going to enter in the time after the football's thrown. So this is 0.5, 1, 1.25, 1.5, and so forth. I'm going to pause the recording right now for you to do the same. Okay, so I've entered in the rest of the data now, and so I'm going to move forward with the questions. In letter A, what we want to do is write down the R value for each of these models. So to start off with the linear model, I'll press Stat, arrow over to Calc, come down to number 4, which is the linear model, select it. List 1 is the X list, list 2 is the Y list. And then where it says store regression equation, I'm going to press vars, Y vars. Function is the first option, so I'll press enter. Y1 is the first option, so I'll press enter. So I'm storing the regression equation under Y1, and that's found here in the Y equals button. So I'm going to go to calculate, press enter, and oops, it looks like in this particular calculator I have not set up the R value to show up yet. So I'm going to do that quickly. This is not part of the normal lesson. This is done in actually part 1 of this series of lessons. So just real quickly, I'm going to hit second 0, catalog, come down to diagnostic on. Selected, it says done, and then I'm going to go back to Stat, Calc, select linear regression, L1, L2, store regression equation under vars, Y vars, function Y1. Now I'm ready to calculate, hit enter, and it gives me an R value of negative 0.565. The 7 would round that 1 up to a 2. And so we'll leave it there. Now let's go on and do the quadratic regression. Stat, Calc, come down to number 5. L1, L2, store regression equation under vars, Y vars, function Y1. Calculate, the R squared value is given, and that is 0.9926. But I need a few more decimal places for when I take the square root. So I'm going to put in a 0.5 there. Alright, now I'm going to take the square root, that's second, and then the x squared button. I get 0.992605, press enter, gives me an R value of 0.9963. Now the exponential value, R value, we'll get that by pressing Stat, Calc, come down to the past the 9 is the 0 option, exponential regression, L1, L2, frequency list. I'm going to skip that. Store regression equation under vars, Y vars, function Y1. Calculate, enter. It gives me negative 0.5933. Okay, so I'm looking at these values here, the R values, and it looks like it's clear that the strongest value that's given is our quadratic value. So our answer here, which model is, it looks like it's going to be the best fit, the quadratic. So I'm going to write the quadratic equation right here. Now, what's shown is the exponential equation, the exponential regression equation. So I'm going to have to redo this again. Stat, calc, number 5, list 1, list 2, vars, y vars, function y1, calculate. Y equals negative 5.31 x squared plus 16.26 x plus 2.56 is my quadratic equation. According to the model, about how long is the football in the air before it hits the ground? Okay, so now we're going to start answering the questions. It wants to know, according to the model, this thing right here, according to what we found in letter C, about how long is the football in the air before it hits the ground? Okay, so in order to answer this question, you got to have some calculator skills prior to this. What I would suggest is to think about what's happening. Here you have time, and here you have the height. And the football is going to be thrown, and it's going to do something like this. It lands at a certain time after it was thrown. And the question is, how long is the football in the air? So it's literally how much time is it from start to finish, from the moment it's thrown to the moment it lands. So this thing right here has a special name, and that would be the x-intercept. It also goes by a few other things. It also goes by a few other names, known as a real zero, a root. It's even the solution of the quadratic equation if it's set equal to 0. In our particular case, let's look at the graph and see what we can do to find this. So I'm going to press calc, not calc, graph, and I see something here, but it's not, there's not a very good window on it, so I'm going to fix the window by pressing zoom, and the 9th option is zoom stat. So this is what's given. Now that's pretty good, but I can't see the X and the Y axis, so I'm going to zoom out a little bit. So what I'm looking for is this place right here on the graph. Where does the curve, where does the model, where does the parabola cross the x-axis? And so in order to find that, there's a skill that ideally you would have learned in a previous math class, in Algebra 1 or something like that, where you press second, calc, second, it's the trace button, but you press second, calc, and what we're looking for is the 0. So we press the 0 button, it's number 2, we're selecting the 0. And what it asks for now is to move your cursor. If you move your cursor over enough, you can see it right here. And I'm going to move it just to the left of this point, so I can press enter. Now I'm going to move it to the right of this point, press enter, and move it back to the middle and press enter. And that's going to give us an approximate 0, approximate x-intercept. So this point right here is the point 3.21, comma. Now, if you haven't seen this sort of number before in your calculator, 2e negative 12, this is scientific notation for your calculator. This is literally 2 times 10 raised to the negative 12. Now if you take a 2 and you move the decimal place over to the left 12 times, that's a 0.0000000000002. I think I got that right. And so the point being is this right here, this number 2e negative 12 is just a crazy way of saying 0. Why would the calculator do that? Because it's the calculator. It doesn't have a brain. It doesn't realize that there's a mistake or an error here. There's a slight rounding error that's occurring. The correct answer is 0, and you, with the brain, have to be able to make that decision. Okay? So, what is the height at this point? Obviously, it's 0. The x value, that's how long the football was in the air before it hit the ground. So the answer to this question, letter D, is approximately 3.21 seconds. Now, would it make sense to plug 8 seconds into your regression equation? Why or why not? This is what it's asking is, does it make sense for us to do y1 of 8?
No.
That's 8 seconds. Why does it not?
Because in 3.21 seconds, it's going to be on the ground.
So what's going to happen?
So by the time 8 seconds rolls around, you'll probably already picked it up and done it again.
Right. So in class, what we've said is, at 3.21 seconds, the football's already hit the ground. So if you keep counting up to 8 seconds, the football's either on the ground or it's on the next play. It's being thrown again. All right. So we're gonna say no, and the answer or the reason being, we'll just say the football is on the ground. It's on the ground. All right, letter E. Would a linear, quadratic, or exponential model make more sense in the context of this problem? Now, here's what I'm trying to get at. Ladies and gentlemen, this is the sort of question that throws a lot of students off. It takes us a lot of effort to get to this point in our study of regressions. It takes us a lot to get to this point. We have to learn how to enter this data. We've got to learn how to process the data, come up with the R values, figure out which R value is the best. We make that decision, we write down the equation, then we start answering some questions based on this particular model. Now, why did we choose quadratic? What was the reason for that here? Because the R value, the correlation coefficient, was closest to 1. But what I'm asking you is, throw out the science for a moment. Throw out the R value, and let's just use common sense. In this problem, does it make sense to use a line, a quadratic, or an exponential function for this particular problem? What makes more sense? The quadratic, right? So in this case, the science agrees with the common sense sort of answer, the context. And that's what I need you to be familiar with, is does it make more sense to the context of the problem? And we're just going to say the quadratic. So it agrees. Now, what restrictions need to be made to the domain? of the regression equation to keep it a good fit. Well, that's getting at the parabola here. Let me just draw another picture. We have data that looks like this. Actual data. And we have a model that does this. We have a model that does that. Do we need the model that goes forever in this direction and forever in this direction? Do we need that? No. So the domain right here was, the old domain was from negative infinity to positive infinity. But maybe we don't need to go all the way to negative infinity. Where maybe could we start? X-wise. 0. We could start at 0 and then we could go up until about what value? 3.21. So let's write that here. We can say 0 is less than or equal to x is less than or equal to 3.21. Now this right here, if you haven't seen this before, this is known as interval notation. Interval notation. Interval notation. Alright, but just for now, we'll just use what you're used to using, inequality notation, which is right here. The values of x in this problem could be restricted to the x values between 0 and 3.21. So, from right here to right here. And everything else doesn't matter. Does that make sense? Okay, so that's number 3, and we've done so many parts in this series online. I'm not exactly sure which part we're on at this point, but thank you for watching, and we'll move on to the next video.